today's webcast, and thanks for making time in your busy day. This is the 10th installment of our educational webcast series called Creating Knowledge Workers for the Greener Product Marketplace. The reason we started this webcast with this theme is because ultimately we do want to create a greener product marketplace, and what we're doing, we collectively, it's all about creating jobs and growing the economy, but in a new way. And so schools, just like any other business, are looking for new and better ways to prepare students and attract the best students to their schools. And manufacturers will recruit out of those schools that are best preparing their students to go out into the world and create change. And so that's what this webcast series is all about, is showing and sharing with everyone the educators who are creating knowledge workers for the greener product marketplace and what they're doing and how they're doing it. So today we are very honored to bring to you our presenters, Eric Reynolds and Ramesh Srinivasan from MIT and San Jose State, respectively, who will share with you their academic backgrounds, professional backgrounds, and the courses they're currently involved in, what the students are doing, and ultimately the impact of this education on students and industry. We will take questions through the questions panel. Probably everyone has been on a webcast before and knows how to use one of those. And feel free to send those in. We'll either take them during the presentation, but we'll also take questions between the two presentations and at the end. So to kick things off, I think a lot of folks who are on the call today are either pretty familiar or passingly familiar with Sustainable Minds, and we're always really excited to be able to talk about kind of the viral adoption of Sustainable Minds globally, both in industry and, to our great surprise and honor in education and in every discipline, business schools, undergraduate and graduate, every kind of engineering, civil, environmental, chemical, mechanical, industrial design, and now architecture. I think that is a pretty clear testament not only to the interest in integrating life cycle thinking and strategies for greener product development, but also a testament to the need for better and smarter tools and the ability to easily transfer that knowledge. So our mission as a company has always been to operationalize environmental performance in product development and manufacturing for the purpose of driving revenue and growth through greener product innovation. And it's really a two-part equation. By first teaching the principles of eco-design, which is life cycle thinking, and then adding technical tools for measuring, you're going to get products that are truly greener. So the thinking differently, the eco-design, the new ideas is where the innovation happens. Using Sustainable Minds to measure, model, and compare is the way to substantiate whether those new ideas are creating meaningful improvements or not. And we like to point out that thinking differently without measuring is no guarantee you're going to get a truly greener product, and often you get unintended consequences. And measuring without thinking differently is also unlikely to get you real meaningful improvement. More often than not, it would be incremental. But by actually thinking differently and applying new kinds of strategies and measuring throughout that process, we believe, and so do lots of other folks, that it gets you to an improved solution and often an innovative solution. So we use the word greener as a placeholder for the term environmental performance. And environmental performance is just the latest criteria in product development that sits alongside functional performance, cost, aesthetics, safety, all the traditional criteria. And now with environmental performance, manufacturers and students and folks looking to make greener products, while they have software and tools and metrics for making trade-off decisions relative to these traditional criteria, they haven't had, until more recently, tools and criteria for being able to make credible, informed trade-offs around environmental performance, and then to make trade-offs between the other criteria and environmental performance. Very clearly, there's real demand, real business drivers from cost of resources, regulation, supply chain risk management, and the ability to create new, greener products through innovative solutions and getting more customers in more markets. These represent real drivers and real demand. And so making greener products should ultimately lower costs, increase the value of the company, and manufacturers who have this knowledge and understanding will achieve competitive advantage. And it brings me to kind of the big idea, which is that manufacturers who are making credibly greener products can credibly build a greener brand. And ultimately, when everything is similar in the choice of products, environmental performance and the belief about the manufacturer's knowledge about what they're doing is going to be the thing that informs that brand preference. And so design and marketing are tightly integrated. So to that extent, Sustainable Minds, for those of you who haven't talked to us in the last year or two, now has products and services for manufacturers not only to design greener products, but to market greener products. And at the end of the day, it's all about making better decisions, better design decisions, better marketing decisions, and better purchase decisions. And so, design and marketing is a continuous improvement loop where you can start wherever you like, either by saying, I'm a manufacturer, I need product transparency, I want to be able to report that in the marketplace, and go through a fully detailed report, and then go back to design and hopefully improve. Or manufacturers can start by saying, I really don't know where I can get meaningful improvements in my products or how to do it. So I'm going to start by designing greener, hopefully improve my products, and then go to market and report. So now Sustainable Minds has, again, products and solutions around the life cycle of design and marketing to drive better decisions and continuous improvement in new product innovation. So going back to the business of today's webcast, eco-design thinking starts with integrating product life cycle at the very core and at the very onset of product development in conceptual design. And statistically, the reason for doing that and financially is that ultimately 75% of the costs are committed by the end of the concept design phase, and that any decisions made after detailed design are very, very costly. So having the ability to understand the impacts and make trade-offs and build models and run scenarios as part of the design process means you can get to better outcomes without spending any more money, because those decisions that get made in early stage design are those same decisions that lock in the environmental performance. So in thinking from a life cycle perspective, we've provided and built on the work of others over the last few decades this eco-design strategy wheel that looks at the life cycle stages of a product and applies strategies that can be investigated in each of those life cycle stages to improve the environmental performance or reduce those impacts by suggesting avenues of investigation to look for meaningful improvements. And so when a manufacturer or a student team is looking to find opportunities for improvement, by benchmarking an existing product or the first concept, you can see where in the life cycle the impacts are occurring, and then go to the strategy wheel, look to the strategies that can be applied in that life cycle stage, and start creating concepts informed by those strategies. Life cycle assessment is the undisputed scientific method globally for measuring the relative greenness of products and systems. There's a standard process which we're showing here. Every assessment starts out with a scope and goal definition. So what are we going to learn? What questions do we want answered? And as a result, how much of the product's life cycle are we going to examine? And we're going to build the inventory for the portion of the product life cycle that we're going to examine, and then we'll look at the impact assessment results from analyzing that inventory and iterate. When we started Sustainable Minds, we brought together two areas of knowledge, manufacturing and life cycle assessment, and so we merged and selected terms from both of those fields to bring together in Sustainable Minds. So we use the term bill of materials, which is a manufacturing term, but brought it together with system boundaries, which is a life cycle assessment term, to create the term the system bill of materials. So what are all of the things that you're going to put into the product system to evaluate? And so this is just a very simple overview of how a system bill of materials can be translated into environmental impacts. So every single one of these inputs can be expressed in chemical data, which is known as process inventory data. When put through the lens of a methodology, all of those impacts can be attributed to one or more categories of impact, and each of those impact categories can be attributed to one or more categories of impact, either damage to the built or natural environment or to human health. So to make life cycle assessment understandable and usable by non-LCA experts, we created our single figure score methodology, drawing from science and data from trusted sources like the EPA and NIST. And what we've done is taken the 10 environmental impact categories from the Tracy methodology, applied the normalization and weighting schema from NIST to create a single figure we call a millipoint score that aggregates the impacts from these 10 impact categories per any particular input. And then we also pull out the global warming score and present that in carbon equivalents. So millipoint score is a relative value, which means the impacts are only meaningful when compared to another millipoint score. The carbon equivalent scores are absolute values. And all of our underlying data is from, again, public and trusted sources that you would find in other LCA tools. So the big idea in Sustainable Minds is to understand there is no such thing as a green product. Green is a relative value, which is why having relative scores makes sense. It's all about comparisons. And so at the heart of the application is the Concepts tab, where the user starts by building a reference model, whether it's an existing product or the first concept that they're investigating, benchmark that score, and then can either copy that reference product or build unique subsequent concepts, and each subsequent concept gives the millipoint scores, the carbon equivalent scores, and the offset, either worse or better, from the benchmark. And at any time, the user can change which concept becomes the reference as you iterate through the process and learn more about it. And for those of you who are designers, you know that design is never done. It's only done when you've run out of time or budget, or you've come to a solution that's acceptable. And so setting goals at the onset of what are you trying to learn and what are you trying to improve is pretty important, because if you haven't said, I'm trying to improve the carbon footprint, or I'm trying to improve the overall scores, impact scores, or something along those lines, then you don't know when you're done. So Sustainable Minds is based on these three pillars of software, data, and collaboration, learning and knowledge management. We have an extensive learning center, which is the equivalent of a 150-page textbook on eco-design and LCA. Because it's in the cloud, it's easy to collaborate, and the use case is to benchmark and compare. We provide quantified estimates of environmental performance. It was designed for non-LCA experts to integrate into product development, and it was the first to deliver a standardized system for comparing product concepts in early stage product development in an understandable and usable way. In the Learning Center, again, there's an extensive amount of content. It can certainly be used in curriculum, certainly as reference material for students to read as they work on projects. There's lots of examples and illustrations. And the most important element of building a life cycle assessment model is having the data to represent all the inputs. And so because Sustainable Minds is a cloud-based application, if you or your students don't find the data that you need already in the data set, we're able to add data that's readily available from other resources, or if you're a manufacturer and you want to be able to model with your own primary data or your own supplier data, we can work with you to add that data as well. There's a data browser. You can browse the data set. We have over several thousand impact factors across the life cycle categories. It's pretty easy to browse. And if you don't see what you need at any point from the browser and within a project, you can actually download this data request form and fill it in, send it off to support, and we can work with you to determine whether the data that you need is readily available or needs to be created. And if you have data that you want to keep proprietary, we can give it back to you in your own private data set, which is at the top of the data selector in the application. To give you a sense of the breadth of the kinds of projects that people do with Sustainable Minds, we have many, many, many case studies. This one I really like because when the Bressler Group gave this case study via a webcast with us, the most exciting thing was the fact that this company hired them to create a new product, and there was no green in the product brief. That wasn't the request, but the fact is that because the Bressler Group designs from a life cycle perspective, they invented a new innovative product that dramatically improved the environmental performance and their cost to manufacture, dramatic reuse, reduction in end-of-life impacts. And their key learning, which I thought was really important, was that, and they said this several times in the webcast, was that every time they thought they had a good idea of something that would improve the performance, when they went to model it, they very often found out that no, that actually wasn't true. And so that was a very pointed example of thinking differently doesn't always mean you're going to get a better result. You really have to measure. And here, on a very granular level, was an example of a manufacturer trying to understand how they could get a handle on all of the ingredients that go into their complete product. And I'm showing you this because I thought this was a great example to illustrate how a designer or the design team can annotate any input into the system bill of materials so that that information is captured for anyone else who's going to be using that model or that project to refer to. And what they were able to find in this first investigation was a way to simplify their modeling rather than by component, by material, quantities of total materials, so they saw that they got equivalent results. And then they were able to learn that in this case, the top 4 materials creating the greatest impacts were the same materials creating the greatest carbon footprint, which is not always the case. In fact, it's less often the case. Usually, some things are creating more impact to the carbon footprint and less contribution overall. And we're going to see an example in the presentation of how students were looking at both the total impacts and the carbon footprint based on what was important to what they wanted to learn. So with that, I'd like to introduce Eric Reynolds from MIT and ask Eric to take it away.
Great, thank you, Terry. So my name's Eric Reynolds. I am here at MIT, just down the street from Sustainable Minds. So I'm an instructor, a mechanical engineer by background. I'm just going to try to shift the slide. And I've been at MIT for about 5 years. So I teach two courses that I developed here, and 2 others that were developed by other faculty. The 2 that I primarily teach have a serious focus on social and environmental impact. So I'll talk more about that. The other thing I do at MIT is run a program for alumni who've started what we call social ventures. So those are hardware-based ventures that are focused in the so-called developing world, and they're trying to get to market at scale. So I do this out of personal interest, but also because our students and our alumni are acutely interested in environmental sustainability. I'll just give a little brief about DLab. So this is the program I work in at MIT. It's fairly unique in that it's in what we call the Department of Undergraduate Education in the Office of Experiential Learning. So our mandate is to be very hands-on, which you might expect at MIT. Not many other universities have a department like this. I'm going to explain this triangle, which is our kind of set of activities. So at the bottom is our mainly academic activities. So these are things like courses. We have about a dozen courses that we run each year. Through those, about 250 students are educated, over 70% of which are female, which is fairly unusual in engineering. And we're predominantly mechanical engineers and quite a few MBAs also. Up towards the top, going up, we have what we call our IDIN program, which is a USAID funded, that's the United States Agency for International Development. It's a government institution that funds this program, which is focused on getting innovators around the world together and creating new products and businesses. So kind of how we do that is imagine about a month-long hackathon in the developing world, so places like Ghana or Zambia. And that creates a lot of new designs, often very innovative product designs, one of which I'll talk about. And that feeds the bottom of our pipeline. So as we go up, this is more kind of research. UROPS stands for Undergraduate Researcher Opportunities, and these are more graduate research. CITE is the other USAID funded program, which is a consumer reports for developing world products. And Scale-Ups is where I work, and we focus on getting products to market. So we do that through entrepreneurship, which I'll discuss, and through working with corporations and large NGOs. I'll just mention that the kind of main arm of that work right now is called our Practical Impact Alliance. Recently, about 10 organizations joined that, including Unilever, Danone, Greif, Johnson & Johnson, World Vision, and a number of others. So they're all interested in getting new innovative products to market in the so-called developing world. So these are our alumni entrepreneurs. We've supported about 18 over the past 3 years. You'll notice a lot of them are in Africa and a lot of them are in India. Healthcare, water and environment. These projects make up the seeds for the class projects I'll discuss. So this is one of the courses I developed. It's called Design for Scale. I teach it with 2 industry professionals, and we designed this about 3 years ago. So this is we ran it for the 2nd time this past fall, and it's mostly juniors and seniors and some grad students, predominantly in mechanical engineering. So we get a few MBAs every year. And this course is set up so that the students are kind of pseudo-consultants. So they work as a kind of consultant design team for a real startup, a real live company somewhere else in the world. And we want to teach them mainly design for manufacturability, so they're given a working prototype and we want them to advance it in some way more towards a market-ready product. So that's usually redesigning some part. So we're kind of at the later stage of concept design, as Terry had been describing it. So it's important to consider the environment in our teaching, and in our first year we did so, but we didn't have sustainable minds to do it. So we, on the board, just went through a simple eco audit by hand. So we did something like this PET bottle and walked through, what are the different kind of energy, like if you put everything in terms of energy, what's required for each of these phases of life. And we use databases like that, which is in Ashby's book. And that was fine in that it illustrates the concept, but it's not enough to allow students to use it on their projects. So this past year, we were able to use Sustainable Minds, and we used a project from a company called Just Milk. Let's see if we can go forward. That project is a nipple shield, which I'll try to paint a picture for you. Yeah, there you go. And you can see it on the left here. It's a product that it transmits either vitamins or medicines into breast milk while a mother is feeding her baby. So this is in preclinical trial in South Africa. Again, this has all been developed by an NGO, a non-governmental. It's actually a 501c3 here in the US called Just Milk. And they submitted the project to our students. And the students' task was to redesign this to be more manufacturable. It's hard to see in this photo, but there's a little lip, which is a fairly serious undercut to injection mold out of silicone. So this was injection molded, but it has to be pulled off the mold by hand, which if you're going to do this in the millions of units, that's a pretty serious cost. So the students came up with some new concepts for this product, some of which are here. Included this extruded flange, which is more injection moldable. This is a dip molded design, which is often used for medical gloves or condoms. And then this is a hybrid in that it has 2 pieces. All 3 of these other concepts are disposable, and that was done because these actually need to be quite clean, otherwise you could reinfect the baby. And then these are places where the conditions aren't very sterile. So in this concept, the base is reusable, but the tip you replace. So that was an attempt, and I'll show their scorecard here, to use way less material. So you can see here we taught Sustainable Minds basically through one lab, which is a short session, and they kind of taught themselves really how to use this, and so they ran through it, and this hybrid concept scored the best in terms of overall performance, and that's predominantly because it uses less material, because you get to reuse this section. In these other two cases, they reduced the material quite a bit from the base concept, and then they messed around some with different materials. So in this concept down here, they use silicone, but significantly less material, and that's where this improvement comes from. Here they used biodegradable nitrile, and that helped boost the score a little bit. In reading their lab reports, there were comments like, I was surprised that the end of life really made very little difference. So going from recyclable to virgin in some cases didn't make a difference for them. So they learned that by actually scoring these things, there are only certain parts of the process that matter for different designs. So in this case, getting material out of it really made the difference. So I mentioned we taught this through a lab. We used an example from a previous class. This is a chlorinator for community water sources. It uses no moving parts, and it automatically chlorinates water in the right dosage. So these students here, a great team, they redesigned this fairly big concept, which requires the pump to be raised in height, to be much shorter and much cheaper. So they turned this fiberglass, biodegradable fiberglass prototype into a thermoformable product in a matter of one semester. And we didn't have Sustainable Minds at that time, so they didn't run an analysis on it, but I went back and did it afterwards as a way to teach this lab. And of course, something like PETG scores much better than fiberglass. So that's a significant improvement. So I think, as Terry mentioned, this is a tool for early stage design when you're in the concept stage. And from my experience in industry, at least in the past, people hadn't thought about the environment until later on, after it was too late and it cost too much to go back and change the design. And when you're early on, you want to be able to compare concepts quite quickly, and this tool allows that to happen, which I've found very useful so far. It also allows trade-offs to become pretty apparent. So in the case of the Just Milk nipple shield, there's a trade-off between the customer experience of having to wash, or at least be careful with that base, the reusable component, versus the environmental impact. So it's very likely that this company, this 501c3, might still go with a fully disposable product just because of the customer experience and the need to have a sterile product, even though that has more environmental impact. But they know now, and they can move towards that with time. So as an educator, just going through that process of being able to see some design trade-offs in real time in a short class project is pretty incredible. And I guess key learnings for industry. So a lot of our students at MIT are keenly interested in benefiting both the bottom line of whatever companies they go to work for, but also other people around them and the planet. These are very complex issues, very complex systems, and it's easy to get kind of tangled up in it all. And so we need tools that can, break it down into manageable steps. And that's one reason I appreciate this tool from Sustainable Minds. There are more and more classes at MIT that are dedicated to this topic. We have a whole new what we call a sustainability initiative. It's been running for a few years, and that's actually how I got connected to this tool in the beginning. Of course, we benefit from more cases, and I think it's easy to say that it's always a trade-off between cost and environmental impact with product design, but that's not always true. So more examples where it actually works out in favor of a lower cost product and a better environmental score, I think are important. And finally, MIT has a culture of taking on big challenges, and the environmental crisis, as some people call it, is a significant challenge and one of choice for our current students. And they want to be able to work on this, even if it's on the periphery or even if it's just small things, whether they're designing a new chair at Steelcase, if they can have an environmental impact that way, that allows them to be more satisfied with their job. And, they're also the key to, people like the students at MIT are kind of key innovators in the world. And if they're not satisfied, they're going to move on to something else. So, that's one reason I think this is important. So I'll stop here for questions, and I think we'll move on to Ramesh also.
Thank you, Eric. That is super interesting, and MIT has a number of labs with really interesting funnels from industry into the university, doing really challenging and important things. So I really appreciate you sharing these stories with us. Yesterday, or the other day, as we were reviewing our respective presentations, Ramesh and Eric had some interesting questions and comments for each other. And so I'm going to invite Ramesh to bring up a couple of the comments or questions that he had for Eric. And I'm certain other educators on the webcast would have similar questions.
Sure. Thanks, Terry. Hi, this is Ramesh Srinivasan from San Jose State. Eric, it was really quite enriching curriculum that you have. I'm sorry, can you hear me?
I can.
Okay. So one of the things that I was interested in learning from your experience was the examples that you showed were quite involved and required a good amount of industry relevance as well as technical details. So how did you bring them into the class set of projects? Did you, I know you have some infrastructure, some organizational setup there. Maybe if you can talk about that a little bit.
Sure. Thanks, Ramesh. So we get a lot of our projects from alumni who've gone on to start companies. A number of others come from companies that we're associated with. Either they're part of that Practical Impact Alliance I've mentioned, or they're just people who come to us. Yeah, so a lot of the projects we get do come from other existing companies, and I like those, especially for this Design for Scale class. A number of ideas just come from the students and from them being out in the field and just seeing problems that are out in the world or opportunities. We have a number of kind of idea accelerators to spawn that ecosystem.
And in what time frame were the students able to accomplish this in a semester or a quarter?
Great. Yeah, so this particular class is a semester class, and they did the Sustainable Minds analysis over a course of 2 weeks. So it's pretty quick.
Right. Thank you.
All right. Well, Thank you, Ramesh, for your questions, and again, Eric, for your presentation. And Ramesh, I'd ask you to take it away.
Thank you, Terry. Thank you for the opportunity to share our experience at San Jose State. I'm a lecturer in the Department of Industrial and Systems Engineering, and I teach life cycle engineering. And in terms of my background, I also launching a software company to assist in the design of solid waste recycling systems. In my career, I've been a supply chain scientist, product management executive, and currently wearing the hat of an entrepreneur since 1986. And I started my career, and I was very fortunate to do so, at IBM Research as a supply chain scientist, and was part of delivering solutions to major corporations like Dell to enhance their supply chain sustainability. And at San Jose State, the program is housed in the Department of Industrial and Systems Engineering, primarily catering to junior and senior undergraduate students. That said, the students come from a variety of majors: industrial engineering, mechanical engineering, chemical engineering, environmental science and studies, and it makes for really a very enriching class atmosphere. As far as the course itself is concerned, most students come with little or no background in life cycle engineering, and it's an elective course. So the very first question I ask them at the beginning of the course is, what do you want to get out of this course? And I get a surprisingly wide variety of answers, all the way from, I want to take something practical and useful for my career, all the way to, well, I want to get a good grade in the class. So we introduce products and processes life cycle assessment, LCA methodology in this class. And the course, with the course, the students learn ways to quantify, analyze, and evaluate human engineering activities on the environment, and to mitigate energy, human, and ecotoxicity. And the fun part of it is that they learn and apply eco-design strategies to develop sustainable product, processes, and service. The way I have integrated this in the curriculum, the sustainable minds in the curriculum, is through an LCA group project. We have about 40 students and have about 10, 11 teams, and they get to work on this for 3 weeks in the semester after they have learned the LCA methodology. And I do an introductory session on sustainable minds, and that's it. They're basically let loose at that point, and they learn about eco-design strategies. And today you will see 2 of the student projects that were selected by a class poll for inclusion in today's webinar. And what you see here is just a bird's eye view of the projects that the students came up with, all the way ranging from suitable materials for laptops, to deodorant sticks, to milk cartons, to using sugarcane versus corn for ethanol production, and life cycle analysis of sauce packets, which was quite interesting. I would like to showcase 2 of the projects from the students. This one is to do with selecting materials for the laptop casing, and the problem they chose to address was to determine which is greener, fiberglass or aluminum. And so for the purpose of the study, they focused on that, and they came out with quite instructive results, as you can see here. The fiberglass has less CO2 emissions, 19 kg CO2 equivalent versus 56 for the aluminum, which is a 66% improvement. And the overall improvement, when you consider the other impact categories, is 78% total improvement. And to the students, it was really exciting to see numerically what it means when they select materials and choose eco-design strategies. And the eco-design strategies that they experimented with were to select lower manufacturing energy material, in this case fiberglass, which is applicable in the production stage, and also how this light material affects transportation efficiency. And the primary learning that they came out with was that the material selection benefits, those benefits propagate through multiple stages of life cycle, in this case production and transportation. And through this exercise, they were able to see not only the CO2 reductions impacting global warming, but also the overall impact across the various impact factors. And another project that really stood out in the class was deodorant sticks. And quite a surprising choice of project. It really speaks to the students' awareness of current issues, as well as how easily they were able to use sustainable minds to accomplish this. And the problem that they were trying to address here was what material should be used for casing, plastic versus paperboard versus recycled HDPE. And the results were quite interesting and to some extent surprising for them. What you see here is the ranking of the materials, recycled HDPE doing the best, followed by recycled paperboard, followed by virgin polypropylene, and then bioplastic. Students were really surprised to see that the bioplastic didn't perform as well as the other materials. And they had experimented with different eco-design strategies, such as utilizing recycled materials and biodegradable materials. Utilizing recycled materials seemed to give the edge to HDPE and paperboard relative to bioplastic. And here again, the key learning that they came out with was that the material selection benefits are pervasive, that which you do right at the design stage, where you lock in the savings. And they were also surprised that bioplastic was not as effective as the other materials. So for the students, they really appreciated the significance of life cycle thinking, coming from various backgrounds where they study engineering, electrical engineering, chemical engineering, where really you go deeper and deeper and narrower. And this was really a broadening experience to learn about eco-design strategies. And they were really excited about using the software to compare impact of product decisions on life cycle stages. I would say many of the calculations that they did during the beginning of the class, which were involved and somewhat difficult, at the end of the class, they saw that the software can do it for them automatically. So the good part is they were able to learn it, so they know what's behind it. And And the good part is also that they don't have to do it going through the nitty-gritty details every time. The software can do it for them. And from an educator point of view, the course emphasizes big picture thinking, and it brings various disciplines together in the classroom. And I found that students really like the marketability of their profiles in the job market when they add this course, and the fact they've used Sustainable Minds software, which is one of the cutting-edge software for students and industry. And it brings home the importance of sustainable development overall as an awareness. And from the point of view of the role that Sustainable Minds plays in preparing students, it is quick and easy, and it is easy to incorporate into the teaching curriculum. As I said, all I did was one class showing them the tool, and then they picked it up. The Learning Center is really comprehensive and helps them not only use the tool, but also learn about the subject matter. And the LCA training through Sustainable Minds rounds out their education across disciplines. And I feel that this could provide even better reach if an online course is offered centered around it. And we all know from an industry point of view that the industry needs students trained in LCA. The whole life perspective in communicating with marketing, design, and service departments is very essential. And upper management needs to get visibility to costs that are normally hidden. And in the age of super specialization, where you go narrower and narrower and deeper, the key to future innovation is hiring people who can bring full life cycle perspective to the design of products and services. And this can't be oversold. It is what it is, the full life cycle perspective. And the industry does recognize that the brand value and sustainability enhanced by infusion of LCA trained employees is key for their growth into the future. With this, I'd like to stop and open for any questions for me, Eric, and Terry.
Thank you, Ramesh. That was great, and I appreciated that you shared the deodorant stick project, and that they selected that. While it seems like it might have been a simple product, the fact is that those kinds of products get mass-produced, in the millions and millions. So, given the subject matter of this webcast was about design for scale, by reducing the impact of the single unit, dramatically reduces the impact, the volume that they manufacture. So seemingly small changes actually at the end really do have a significant impact. So it was nice to see a project like that. Eric, you had some interesting insights and questions for Ramesh the other day. I'd be happy to have you share those.
Sure. Nice presentation, Ramesh. So
Thank you.
I'm fairly new to LCA, and one criticism or one concern I've heard is that you have to be quite careful of what data set you're using or the tool. For instance, Sustainable Minds is using. Sustainable Minds does a nice job of being very transparent with the data, but I know that some data, can have regionality, or it can change based on, where the product might be manufactured, for instance. So is that true, and how do you consider that in the classroom?
No, that is absolutely true. And one of the things that I tell the students is in doing analysis like this, you want to start with simpler assumptions and do a first pass analysis, which then allows you to focus on specific stages of life cycle or specific choice of material or geography. In that sense, Sustainable Minds is an excellent tool because it's simple and you don't need to bring all the details into account when you start, because it provides some of those, and that's why they call this also the screening type of software, because you get through the 90% accuracy and comprehensive nature of your analysis, and then you can focus on specific details such as geography specific and other specific aspects. Does that answer your question?
That does. Thank you, Ramesh.
I want to thank both of you for sharing your stories today, and I think they really underscored the intent of this webcast series. And clearly, the students coming out of your programs will definitely have an advantage in the marketplace. As you both have kindly pointed out multiple times, our intent is to create software that's easy to use, really leveraging the cloud to its greatest advantage, and offering products that are affordably priced so that people can actually bring them into their workplace, and from a student perspective, can actually take them into industry with them. We have ability to purchase online. We have a 15-day free trial, which we encourage folks to check out. We also have quantity discount pricing for education in packages of multiple students and multiple educators. It's our vision that at some point in time that every school will have site subscriptions to Sustainable Minds, and that every student will have access to be able to integrate into their knowledge and learning. We have a nice curriculum library where faculty who have participated in our webcast series have donated their curriculum, which we can offer freely available to anyone who requests it. And of course, all the webcasts that we've given in this series are online. You can find them here, and the link was also in the webcast invite. This presentation will go up in a day or two, and we invite you to keep in touch. And if you have any questions, you can pass them on to Ramesh or Eric. Questions for us, please contact us at the address or phone number below, and we'll be reaching out to you as well. So I want to thank all of you for making time in your day, and again, thanks to Eric and Ramesh, and we hope to speak with you all again soon. Have a great day.
Thanks, Terry.
Thank you, Terry. Thank you, Eric.
Bye, Ramesh.